Now, this is a quick video showing how to use the room survey component. The first important thing to note is that room survey was developed to be used interactively, ideally in a web environment such as a browser or an application. It allows you to produce a step-by-step workflow to survey existing rooms. The idea is that all inputs of the component will be connected to a web application that collects user inputs. Now, suppose that you or your user are inside a room such as this one, and you want to produce a polygon that represents this room plan. You can measure the internal dimensions of these sides, but you cannot measure the internal angles here and here, at least directly. What our component requires is that you provide a room morphology, which is a similar polygon that has the same order of internal corners. So in this case, this is a convex corner and this is a non-convex corner. So the order of these corners has to be the same. It doesn't matter the rotation, the scaling, or whatever. The only important thing is that these corners match. So to give some user feedback, you can always use something like this to number the corners of your polygon. So you provide this morphology to our algorithm, and we can simulate the process of measuring the internal sides of this existing room here using, for instance, this explode component and measure the internal lengths of this room. So we need to provide the lengths of this room in a counterclockwise order, so the same order as the morphology. So the first thing that the algorithm does is check if your actual room can close your polygon, your side lengths can close the polygon using the existing internal angles of the room. In this case, note that I'm using the same polygon to provide the same polygon to the component, so it closes automatically. But if I am to change this to this polygon here, it notes that your room sides dimensions using the internal corners of your morphology will not close the polygon, so you're required to measure an internal diagonal. So it tells you that you need to measure the diagonal between point 0 and point 4. So this is point 0 and point 4. So you measure this diagonal and you provide this. In this case, in Grasshopper, you can use a panel to do that. But in a web application, you would likely use a JSON object or something like that. So the diagonal is 12.577. We provide this to the component, and the next thing he asks is to measure another diagonal, since it doesn't close the polygon. So it was requesting the diagonal between point 1 and point 5. That is 9.837. And then he requests another one from point 3 to point 5. So this point 3 and point 5. And that is 9.249. So with these three diagonals, he was able to close the polygon and provide, you can, in this output, the shape of the room with the provided diagonals. So you have the shape of the room corrected by the internal diagonals. And you also have an output that tells you if the polygon has been triangulated. When he's able to close the polygon, it outputs to true. You may use this to downstream something you want to do out downstream in your application. Suppose that you could not measure one diagonal that the algorithm requested, for instance, the first one, so from point 0 to point 4. So you can always return -1. And the algorithm requests some other diagonal to replace it. In this case, the order was the same, so it requested point 1 to point 5, and then point 3 to point 5, and now is requesting a diagonal from point 2 to point 5, so from here to there. And that length is 7.880. 7.880. Okay, now it's able to close it also. Of course, there's a limit to the number of diagonals that you can deny. He always needs at least n-3 diagonals in cases like, for instance, you have a polygon with 6 sides. He always needs at least 3 if all the sides are non-orthogonal.